Hello, and welcome to Functions Algebraically. My name's Tuesday Johnson. Here's an introduction to a concept with applications. Alright, so let's start with the definition and notation. Okay, so we're going to have a definition of a function. A function f, and why do we use f for a function? Mathematicians aren't all that clever. We try to make it easy. We try to keep it like what it means. A function f assigns to each element x in a certain set a single value f of x. Well, this input x that we see here that goes into the little function machine, it's called the argument of the function. It's called an element of the domain of the function. And it's the independent variable. It's independent because we get to choose it. The outputs, however, the outputs are the value. So the argument is what we're talking about. What pops out is the value. The input is in the domain. The output is an element of the range. Although x is independent, once we put something in the machine, the y value, the f of x value is dependent because it depends on what we put in to get the machine going. Right? It's like a juicer. If you're putting carrot in, you're going to get carrot juice out. Right? You can't put in a watermelon and expect carrot juice. Of course, why would you expect carrot juice when you could have watermelon juice? Okay, so a function, right? A function versus an equation. They're essentially the same thing, but mathematicians have different uses for them. Sometimes we want an easy little, let's just call this y. Sometimes we'll call it f of x. But we always have to remember that y depends on what the function does to x. Okay, y depends on what the function does to x. This is how we relate functions to equations. We could have a function notation, f of x equals 3x minus 2. And equation notation, we would just call it y equals 3x minus 2. These are the same. It is a little bit different because of function notation. If you're asked, write the function, you would use an f of x. If you're asked, write the equation, you would use a y. But they represent the same thing, all right? Just simple notation. It's just, do you use an f or just an equation? I'll use a y because we're so used to that. But mathematicians, just like f for function, a cost equation is probably going to be C. A revenue equation probably going to be R. A temperature equation probably going to be T. So mathematicians like to use letters labeling the functions effectively, and that's why we use an f, just because it's such a generic function. All right, so how do we deal with these functions algebraically? So let's evaluate the function at the given value. For f of x equals negative 3x plus 2, we want to find f of negative 1. So what I start with is what's called the skeleton. All right, the skeleton takes out the x, and everywhere there was an x, we replace it with parentheses. So just the function is something, right, equals negative 3 times something plus 2, and I just use empty parentheses. Now I want to substitute a negative 1. So I'll put the negative 1 in my parentheses in both places to flesh it out, right? So the skeleton, we leave out the variable, replace it with parentheses. To flesh it out, we make that substitution. Now x is negative 1. Everywhere there's parentheses. And then we'll use the order of operations to find negative 3 times negative 1 is 3 plus 2 to get us our 5. Right, this is called the skeleton method. I didn't develop it, but I use it quite a bit. Let's try this again. For f of x equals x squared minus x plus 1, we want to find f of 3. So I start with the skeleton. Okay, what does the function say? The function of something, parentheses, it's almost like I took that x apart and turned it into a set of parentheses. Something squared minus something, so everywhere there's an x, there's parentheses, plus 1. Now, that's my skeleton, right? That's just the structure. That's just holding us all up. Now, the guts are going to be the 3. The flesh. Let's call it flesh. It's a little, oh no, it's almost, as I'm recording this, we're in the middle of September, so it's flesh and guts? I don't know. Spoopy season's almost here. Skeleton. Now we'll put in that 3. This time I didn't put it in color because you don't need it in color all the time, right? We want 3. So we put 3 inside the parentheses, everywhere we see parentheses. And now we'll complete our order of operations. We have a 9 minus 3 plus 1. And we can do that. 9 minus 3 is 6. Plus 1 to get us to our 7. All right, so if you start with the skeleton, you start with the structure, it makes it harder to incorrectly use our values, and especially when there's a negative involved. I really like this with the parentheses first because so many people forget parentheses with negative values, and when you square it, it matters. It really matters. So I encourage you to use the skeletal idea. Okay, so we're going to find the following. Now it's our turn to use it. I just got to make sure. Okay, yeah. F of a. Okay, so f of x is x squared plus 4. So f of a is something squared plus 4, my skeleton. And then I put in an a. And then, of course, we'll simplify. And simplifying is really no better, whether it has the parentheses or not around the a. It's the same thing. You didn't have to simplify that, but, it's less to type in if you're using an online homework system. Now, f of a plus h, that's a different monster entirely, right? Same structure. We have something squared plus 4. But this time, instead of just putting in an a, replacing an x, I'm putting in an entire expression. So in place of the x, I want all of a plus h. So now I have a plus h all squared plus 4. But remember, if something is in parentheses squared, you're multiplying it by itself. So let's go ahead and write that down. All right, we're not just squaring the a and squaring the h. It's actually more than that. You have to take a plus h and multiply it by itself, right? 2 times. Now, as we multiply, don't forget, we're going to distribute a squared plus ah. I'm not going to call this ha. I'm going to always go alphabetically. So I'm going to call that ah again. And that's an h squared. And don't forget your 4. The 4 frequently gets forgotten, or anything else after you do the square, because that was a lot of work. But we're going to keep going. A squared. There's no other a squared here. I have an ah and another ah, so I have 2 ah. And an h squared plus 4. Notice there are no other like terms, so we would leave our simplified answer as a squared plus 2ah plus h squared plus 4. This is the simplified version. This is correct, but it's not simplified. It's not going to help you for the next steps that we'll have on some problems. All right, let's talk about those problems. G of x equals 3x squared minus 1. Find the following and simplify. So I want to look at g of x plus h. Well, g is the name of it. It tells us right here what g is going to do. G will be 3 times something squared minus 1. I always start with the skeleton. Here we'll want a little x plus h because that's what it's telling us to put in. Now over here on side work, I have x plus h squared, which is x plus h times x plus h. And remember, we're going to multiply that out. We call it FOIL because the acronym first, right? We multiply the first, multiply the outside. That's a plus sign. That is not a times. That was me forgetting what I was writing in the middle of writing it. We've all been there, right? X squared plus xh. I know I just said I do it alphabetically, but for some reason I didn't. Plus hx, so I'm going to call that another xh and h squared. Notice that these two in the middle will combine just like they did in the a plus h. And now I switch it to hx. I know. It's hard to keep up with me sometimes. Okay, so this, put that down on a little note card and keep it so that when you're doing these problems, you automatically go from x plus h squared into this. All right, you're going to either do it so many times you have it memorized, or little cheater note card right there that you know, don't use it on the test or anything, but you can use a little note card to help you remember. So this x plus h all squared is going to be x squared plus 2xh plus h squared. Now, you did all that work, but don't forget the 1, right? Don't forget the minus 1. Now we'll distribute 3x squared plus 6xh plus 3h squared minus 1. All right, and that's it, right? Nothing else combines. There's no other x squared, there's no other h squared, there's no other xh, and there's no other just number. But you see, then we could do something like this. G of x plus h minus g of x. So we'll take what we already found. I'm not going to do it again. I just found the answer. Let's use that. We're going to work smart, not too hard. But then we want to subtract the original function. So if I'm going to subtract, I'm going to put the whole thing in parentheses. So I remember that that negative goes to both of them. So this becomes 3x squared plus 6xh plus 3h squared minus 1 minus 3x plus 1. Check this out. I'll use yellow. Oh, I wrote something wrong, so I have to fix that first. This is 3x squared. Always pay attention as you write. If you get in too big of a hurry like I just did, it's so easy to make mistakes. But this 3x squared and this 3x squared cancel each other out. This negative 1 and this plus 1, they cancel each other out. Notice everything we're left with has an h in it. Anytime you have one of these, highlighter, I don't want the highlighter. There we go. Oh, I'll get it together here. Every time you do one of these problems and you get to the g of x plus h minus g of x, or f or h or whatever we happen to be calling, please don't call it h of x in this case. Always the original function terms are going to cancel out, and it's these terms involving h that we have remaining. 6xh plus 3h squared. And so we could use this answer in here. This is a 3-step problem. You'll frequently just be asked for part 3. I always build it up slowly. I'll do g of x plus h, and then I'll do the numerator. Hey, look what I have right here, 6xh plus 3h squared. Now this step, all I have to do is divide it by h. When I'm dividing, I'll always factor out first, because we can only cancel numerator to denominator if it's in factor form. All right, so it has to be written as factors or a multiply problem before we can cancel. And we'll end up with 6x plus 3h. Now, for those of you wondering why would we ever do this? Mathematicians are a little weird and we like it. But also, this is the basis of half of calculus. So if you can understand this process, if you can get this algebraic process down, you'll do quite well in applied calculus or calculus for business majors. So this is a really good one to keep in mind. It's a foundational for like a next class if you have to take a next class. All right, thank you for watching. Be sure to subscribe to Math with Tuesday on YouTube. I appreciate it.